Okay, good evening to one and all. Today, actually, three topics I am planning to discuss with you. First one is load sharing concept of auxiliary converters in three-phase locos, maybe WAG9, WAP7, WAP5. All are common. I will explain the concept. Then angle transmitter logic, how angle transmitter works, how torque has been generated from angle transmitter, how it is sensed and how it works. And then third one is important but not a vast topic, a small topic only. Transformer oil temperature, logic. How isolation has been initiated, how it senses, how it works. Okay. Okay. First, before going into BUR load sharing concept, what are the auxiliary loads available in three-phase class of locomotives or its cooling concept? That should be understood. Then only we can understand the load sharing concept. So you all know that totally if WAP7 or WAG9 is there, how much TMs will be there? 6 TMs will be there. For WAP5, 4 TMs will be there. It will be distributed half between bogie 1 and bogie 2. Okay. So for cooling the traction motor, air should be given in a high velocity and high volume. For that, one set of bogie is having one traction motor blower and second set of bogie is having traction motor blower 2. Okay. This is driven by, that is TMB1 and TMB2. Both are driven by BUR2. We all know that 3 auxiliary converters are there. Okay. In that, BUR2 is driving TMB1 and TMB2. Okay. Now it is clear. That cooling part of traction motor blower or traction motor is over. Next coming machine room. We can see that while we walk from cab 1 to cab 2, in between loco, one corridor is there and 2 sides are there, where SR, BUR, VCU, SB panel, everything is located. So, beneath that, we are seeing duct. Duct means what? Some part which carries high pressure air. So, if we check behind VCU, behind BUR, everything, and underneath also, behind also, duct will be opening and through that air will be coming out. Those who have worked in PPO may have checked airflow velocities at the back side of BUR, back side of VCU, everywhere. Okay. So, for cooling that machine room equipment, which are distributed in both sides of machine room corridor, 2 blowers are there. That is machine room blower 1 and machine room blower 2. All these motors are 3-phase motors. But previously, in the initial design of the WAP7 locomotive, machine room blower was given single phase supply only. Okay. So, we will be having doubt how single phase supply can run a 3-phase motor. In that, split phase concept is used. For that, some capacitors have been brought and timers have also been introduced. Many of people may have seen messages machine room capacitor blower not open while analyzing data and while PPO checking also you may have seen, because in previous design some capacitor split phase concept was introduced to make the motor start and after that it will run continuously. Why? Because it was driven by single phase supply. But now concept has been changed. Both motors are driven by what? BUR2. So it will directly get 3-phase supply, soft start also. It will run continuously without no issue. It will cool auxiliary converters, VCU and machine room equipment. Okay, that is its function. And next one is most important, and I have to explain a lot for this. So, cooling circuit. Till now we have seen air-based cooling, forced air cooling. Now we are going to forced liquid cooling, which is cooled by air again. Okay, that concept will come here. So for cooling of traction converter 1, traction converter 2, then under gear what is there? Big transformer is there. That transformer also to be cooled. For that also a combined big cooling circuit is there that I will explain one by. Okay. Initially under gear we know that one transformer is there. For hotel load locos, it is 7775 kVA. So it is full of oil. That oil should be pumped with two pumps, transformer oil pump. The first pump is monitored by SR1, traction inverter 1, and second pump is monitored by SR2 or traction inverter 2. Okay. And this oil will be pumped to radiator. Its radiator is having two layers. Why? Because I will tell you. And this radiator is cooled by forced air, which is coming from oil cooling blower. Okay, that will cool this one, and again this pump will give it back to transformer itself. So from top of the, we know that in a fluid, top portion will be always having more temperature. Why? Because density is less, it will come to topper portion. So from top of the transformer, oil is taken, pumped and transmitted to radiator. It is cooled by air cooling of oil cooling blower and given back to transformer to bottom portion. Similarly, this side and for this is monitored by SR2. Understood? And coming to top part, in machine room, we are having two traction converters, one for bogie 1 and one for bogie 2. In that, previously we were using GTO, but now we are using IGBT based technology. So this is for old circuit. Valve sets were there. It was cooled by oil, but now coolant is being used. Ethylene glycol mixed in water. Clarine, its name. Ethylene glycol is mixed with water and it is used as coolant. So for SR1, one coolant pump is one coolant pump is there. For SR2 also one coolant pump is there. SR1 coolant pump will circulate the oil to top portion of radiator. Similarly, SR2 also. But both of these circuits are different. And its pressure or flow will be always monitored by concerned SR also. Okay. Here also at the top portion of the radiator, which is cooled by oil cooling blower, will ensure that the temperature of this coolant, this transformer oil here and here, temperature is not rising too much. Its temperature is also being monitored, its pressure is also being monitored. So all these pumps 1, 2, 3, 4 plus 2 oil cooling blowers. It is controlled by, these 4 pumps are controlled by BUR 2, and OCB 1 and OCB 2 are heavy motors which are controlled by BUR 1 or driven by BUR 1. Okay, this is the overall cooling concept of 3-phase loco. Apart from this, 2 more vital and important motors I want to tell, that is not involved in cooling, it is involved in functioning of brake system, which is CP1, CP2, compressor 1 and compressor 2. That is driven by BUR 3 or auxiliary converter 3. Okay, now concept is clear. OCB 1 and 2 is driven by BUR 1. Okay, then all the remaining motors which are shown in this page are driven by auxiliary converter 2. Then coming to pneumatic part, CP1 and CP2 are driven by BUR 3. Apart from that, one more thing is there, battery charger, that is also driven by BUR 3. Okay. So all loads which are coming under BUR have been covered over here. Okay. So this is the distribution. This is the distribution when all the 3 BURs are in service. Means auxiliary converter 1, 2, 3. All are healthy, all are working. At that time only this load distribution will be applicable. Okay. First one, OCB 1 and 2 by BUR 1. Then BUR 2 drives all the remaining motors except compressor 1, 2 and battery charger. Okay. Now the concept is clear. Next I am going to introduce one more concept, which is, we know that here fan is there. This is BLDC fan. If induction motor is used, whatever voltage and frequency we are giving, its speed will be proportional to that fan speed, or reverse. Whatever frequency or voltage we are giving, the fan speed will be proportional to that only. Because flip frequency is creating torque to rotate the fan every time. So, why I am telling means, if we want to control the speed of these motors, we can control what? Voltage of the induction motor, what we are giving, or frequency of the supply, what we are giving to that motor. So, next I am going to introduce one more concept. It is called ventilation level. So, now December has completed. December days, you people may not have used the fan so much. Or if you are using, you will be using only in speed 1 or 2. That is enough. Why? Because less cooling is only required because atmosphere is almost cool. And next condition. Now we are in March. Full speed surely we will be using fan because more cooling is required. Similar to that, loco I told you one coolant is there for SR1 and 2 cooling. Second, transformer oil is there. Both of them should be within a limited temperature. Otherwise, loco will overheat and we cannot work further. So, based on the temperature what these fluids are having, they have defined and given some ventilation level. Okay. The temperature also I will tell you. So, based on that temperature only, in what speed the BUR should control the fan. That concept is being derived. Okay. So, earlier during Mika's loco period, lot of concepts were there. Step 1 was the motors will work. That is OCB like motors will work with 5 hertz speed and small voltage, less than 50 volt. So the speed of that OCB will be very less. Why? Because cooling required is very less. And second speed, that was 17 hertz. 17 hertz means voltage will rise nearly to some 100 volt and it will work with 17 hertz. That was ventilation level 2. The next step was 37 hertz. That now also ABB locos, higher locos, everywhere it is being followed. 37 hertz means instead of running in some 50 hertz speed, it will run in some 37 hertz speed corresponding to that. Okay. And final and most important, when higher prior cooling is required means it will run in 50 hertz speed. Okay. This was the concept with old Mika's locos. But now, which all locos are available, either BUR 1 will not work because temperature is less than some 30 degree or 20 degree for both transformer oil and coolant. So there is no requirement of cooling at all. Radiator will be under less heated condition only. So it will not work at all. So PPO testing, people may have experienced OCBs not working. Lot of bookings I am getting, that's why I am telling. Okay. So don't worry. DJ close பண்ணா temperature கம்மியா இருந்துச்சுன்னா BUR 1 work ஆகாது. Okay. For all locos it is like that only. இன்னும் அது எப்படி கண்டுபிடிக்கலாம்? For that, in driver display unit, ventilation level one option is there. That option you can check whether it is in 1, 2, 3 or 4. If ventilation level is not at all there, that means cooling is not required, BUR 1 will not work. Okay, that is the concept. Coming to BUR 2. BUR 2, all these loads I told you that oil pump of converter, oil pump of transformer, everything whose pressure and flow of fluid is monitored by traction converter. So, all the time that BUR 2 should work in 50 hertz with 415 volt output. Otherwise, what will happen? Traction converter will sense that transformer oil pressure less than limit or coolant pressure is less than limit and it will trip and isolate. So, always BUR 2 will be working in 50 hertz 415 volt supply in normal condition. Okay. Now understood. BUR 1, there is no requirement of working in all the time because whenever temperature is higher, that time only BUR 1 requires working properly. Okay. Then second BUR 2, since its output is being monitored by SR1, SR2 in form of coolant pressure or transformer oil pressure, this should work always in 50 hertz when all BURs are in service. Okay. In some locos, means in BHCL locos, high-rec locos and all, if any of the BUR is got isolated means automatically the load in other two BURs will be very large. it cannot withstand that much kVA during starting or normal running. So at that time BUR 2 will work with 37 hertz. Okay, so that is not an abnormality. And in last 1 month I have got around 10 to 20 bookings that when BUR 3 isolated, battery charger is not working. Actually, in that condition battery charger is working, but since the BUR output is less, the battery charger voltage deviation will be also less only. Okay, because it is working in only 37 hertz and less voltage. Some less than 350 voltage will be only induced in output side of the phase value. Okay, that's why when any of the BUR is isolated condition, BUR 2 will work with 37 hertz only. That is not an issue. It is a software load. Okay. And coming to BUR 3, maximum time the BUR which is restarting is BUR 3. Why? Because every 2 or 3 minutes or every 5 minutes, our MR pressure will be dropping continuously. So in order to recharge it, and CP1 and CP2 are actually heavy load. So soft starting is required. Operation of unloader is also required. That time the BUR 3, if it was working previously, will ramp down to 18 hertz and voltage will reduce to less than some 50 volts, and then it again build up to 50 hertz. And this process keeps on repeating because compressor is heavy load and it is in need of frequent starting and stopping, starting and stopping. Okay. And battery charger also. Whenever compressor is getting ramped in and ramped out, same time battery charger voltage also will dip and again it will come up. Why? Because the output of BUR is getting reduced and again it is coming back. Okay. This is normal condition when all BURs are working. எப்பவுமே BUR 3 இருந்தா பேட்டரி சார்ஜர் ஒர்க் ஆகும். இன்னும் BUR 3 தான் என்னது இருக்கு, கம்ப்ரஸர் இருக்கு. அப்ப கம்ப்ரஸர் எப்போ எல்லாம் ராம்ப் அப் ராம்ப் டவுன் ஆகுதோ அந்த டைம்ல எல்லாமே என்ன ஆகும், பேட்டரி சார்ஜர் வோல்டேஜ் கம்மியாகும், திருப்பி ஏறிட்டே இருக்கும். ஓகேவா? Then about ventilation level, what logic they have used? I told you two temperatures are being monitored. One is coolant, second one is transformer oil temperature. So for value, ventilation level is 0, means BUR 1 is not at all required to work in the condition from 0 to 48 degrees Celsius of transformer oil temperature. Okay. Second level is from, means ventilation level is 1 from 48 degrees Celsius and above. அது வந்துச்சுன்னா BUR lower speed, BUR 1 lower speed start out. Then ventilation level 2 after 50 degrees Celsius and 55 degrees Celsius and above, it will work with full output. That means full frequency and full voltage. Similarly for SR coolant temperature also, this level is defined. So whichever is coming first at higher value, that will trigger BUR 1. Okay. அப்போ இது எந்த வென்டிலேஷன் லெவல்ல ஒர்க் ஆகுதுன்னு பார்க்கணும்னா, டிடியூல ட்ராக்ஷன் கன்வெர்ட்டர்னு ஒரு ஆப்ஷன் இருக்கும். அந்த ட்ராக்ஷன் கன்வெர்ட்டர் ஆப்ஷன்ல போய் ப்ரெஸ் பண்ணியாச்சுன்னா அதுல வென்டிலேஷன் லெவல்னு ஒரு ஆப்ஷன் இருக்கும். அதுல ஏதாவது ஒரு எஸ்ஆர் வென்டிலேஷன் லெவல் 1, 2, 3 இப்படி ஏதாவது வந்துச்சுன்னா then BUR 1 will start working. Otherwise BUR 1 will not work. Traction converter option after ventilation level എന്നൊരു ഓപ്ഷൻ ഉണ്ടാവും. അതിൽ 0 above ഏത് വാല്യൂ വന്നാലും BUR 1 should work. Okay. ഇന്നു ലോഡ് ഷെയർ. ഇതുവരെയൊക്കെ നമ്മൾ சொன்னது all BURs are in service condition only. Now any of the BUR is getting isolated, then how will be the load distribution? Okay. This is normal circuit. Normal circuit la BUR 1 will drive 2 OCBs, BUR 3 will drive CP1, CP2 and battery charger, and all of the other motors are driven by BUR 2. So this is not important for us. For us this table is very very important. That means for making this output of BUR available to load in all conditions, some contactors have been placed. Some are inside BUR and some are inside panel, HP panel. Okay. So that contactors will open and close accordingly to redistribute the load when any of the BUR is not in service. That concept only we have to understand. Okay. அதுக்கு mind le edum vechukka thevilla. Only thing is this table should be in your phone always. Okay. So here it is given that normal means all bars are in service. You take the phone and go near this contactor, whether it is closed, this is open, this is closed, this is open, like that you check. Okay. If all these things are okay, then you check all the motors are running or not. Provided bar 1 only I told you, if ventilation level is not there, there is no need of running. So only thing you have to check is if all bars are in service, all these contactors are whether in open condition or closed condition. Okay. Then you go to motor side and check all motors are working or not. That you can hear with your ears. That is only required. Second one is when bar 1 fails, then its load is there OCB1 and OCB2. That will be shifted to bar 2. Okay. That is controlled by, you see that this normal sequence is different from when bar 1 fails. Okay. You go with your phone, again check all these contactors positions are as per this chart which is given here. Okay. If it is not okay, then what will you do? அதுக்கு உங்க circuit bookile page number 5I to 5M some circuits are there. Okay. That I have not shown in this PPT because it will take a lot of time to explain. Okay. இப்போ ஏதாவது ஒரு bar isolate ஆயிடுச்சு. This contactor sequence you can see now physically whether it is opened or closed. That is not as per this chart. Then you have to see page number 5I to 5M in your circuit book. What you should see, I will tell you. First, which contactor from this has not maintained this chart. That contactor you pick. Okay. Then see its circuit, see its positive supply is coming or not when isolated condition. If supply is coming, then you check. If supply is coming, then also contactor is picked up or not. That also you can check. Then third thing is the contactor is picked up. Then also this is not working means contactor will be having some interlocks. That interlock supply has not gone to BUR. That is the problem. So control supply which is giving feedback you have to check. That is the normal procedure. Mostly interlock issues or couplers and connectors are involved in this. That pins will be having loose contact. That type of issues only we are facing. Okay. This is load distribution in condition. Then all bars are service. Then all load sharing when one bar is isolated. Contactor position and contactor sequencing is explained in this diagram. And this is load distribution when that bar is isolated. Bar 2 is isolated. Similarly, for all 3 bars when isolated, which all loads will be driven is given in this PPT. I will share it. Then how to check it is in DDU, driver display unit. First, this 2 portions are there. This orange color menu button in ABB locus and CGL locus you can see. That you can press. Then it will go to an auxiliary converter menu. That menu is pressed means you will get bar 1, bar 2, bar 3 values of DC link voltage, output frequency, everything you can see. Okay. Instead of physically checking, this one also you can see in driver display unit. This is for BTIL. In that operation menu is there. In that auxiliary converter, your option is there. This is touch screen. You can click it and you can get the value of bar 1, bar 2, bar 3, frequency, voltage, everything. And also important contactor position will be marked in this also. Okay. Before this, one more thing I can tell you. Only in MEDA propulsion locos, I told you now, ventilation level is not coming means bar 1 will not work. But MEDA display is having one test facility. In that testing option you can give and bar 1 you can run at any time. Okay. Clear or not? Only in MEDA locos with the driver display unit you can bring bar 1 into service and test whether it is working or not. Okay. That's all. Then angle transmitter. Okay. What is the function of angle transmitter? First function is to select the direction, forward or reverse. Okay, that is accomplished by this portion. That means here if it is white color means circuit will be incomplete. Sorry, circuit will be complete. It will be having continuity. And if it is black colored, it means that that is an insulated portion. Circuit will not be complete. So suppose loco pilot is providing this to forward position. Okay. So the output of this will be here, positive. So whatever 110 volt supply which is coming here will go to this card. This card is called STB1's DIO card, digital input output card. Okay. And second interlock also, it is in forward, so supply will go to here. Third one is forward means its supply output will not be there because this is black portion. Okay. F4 anga black thaan potirukku. That means this is not having continuity from here to here at F position. And fourth one also continuity will not be there. So if this one is 110, this one is 110, this is 0 and this is 0 means what? Driver has selected forward direction. This way VCU is sensing which direction he has selected. Okay. And second thing, how much torque or how much speed we want to attain, we are giving in terms of angle. If we are moving it more forward direction, more torque it will develop. That is, if forward direction we have put and we are moving the pedal to front direction, it will work as tractive effort increasing. Okay. So for that, two things are there. One is an analog input. That means if you are varying the position of the rod from 0 to 100%, 0 to 24 milliamps current will be given to VC. That is analog input. Okay. Suppose you are keeping it in 50% position, you will get 12 amps output. Like that. Its output will goes on increasing as you move or increase its angle from 0 to maximum position. Okay. That is sensed by analog input output card of VCU. That is this part. What if suppose this analog part has failed? Then we are having at SB panel one failure mode switch is there. That switch we can put it in failure mode. Then this analog value will not be sensed. Instead of that, digital value will be sensed. Digital means it is having some interlocks at 0 position, 1/3 position, 2/3 position, and maximum position. That digital values will be given by this inputs of angle transmitter to VCU. Okay. So even if analog fails, we can drive the locomotive through this interlock. So all these positions are inscribed in this, and based on the output that 0, 1, 1, 0 like that combination will be there. Based on that, VCU can sense and find that which position we have placed it. But the operation will not be smoother since we have lost the analog value. We will get only 0, 33, 66 and 100%. That's all. Okay. This was previous concept, and now if what happens, this card fails, VCU. Then also we have to clear the line. So we have introduced redundancy. That I can tell you. Here also color you can see this is white throughout here, and here it is throughout black. Means if we are keeping in 1/3 position, TE means tractive effort. Similarly, if backward direction we are pressing means it is regenerative braking. So that is explained by BE. Okay. Both are same only, but in which direction we are moving, based on that only VCU will take the input. Okay. So suppose I have placed it in tractive effort position 1/3 position. So the input given by this will be what? 1. Means 110 volt is available here. So this card will get 110 volt. This will not get 110 volt. This also will not get 110 volt. And here also will not get 110 volt. From this, you can read that we have placed this in 1/3 position because 1 0 0 0, which is 1/3 tractive effort is defined. in VC programming. Okay. Similarly for all the positions. Here 2 more positions are there. Here also 3 more positions are there. All these are defined in VC. So I am asking, what if any of this card fails? Then also we have to drive the locomotive. For that, MX435 redundancy wiring is there. MX435 was introduced by RDSO. In that, additional digital inputs parallelly have been sensed by some other cards in the same ECU. Okay. Previously, here only 4 were there to sense the input. Now, what if this card failed means parallelly 4 more are given. If this card fails, this will sense the input like that. So redundancy is introduced. Okay. Now this wiring has been used in most of our locomotive, ABB, CGL, TCN propulsion. This has been used. Okay. This is the angle transmitter concept. Then coming to calculation, there is one more thing. We have seen many messages that angle transmitter failed, angle transmitter failed. Why that message is coming? So suppose we have given 1/3 value. So the analog output we should get how much? 1/3 means if 100% is the full value, 1/3 will be 33.33. Okay. If this is getting some 10 and this is giving some 1/3, what is its meaning? അതായത് ഇതൊരു 1/3% മീൻസ് 33% ഔട്ട്പുട്ട് കിടக்கிற மாதிரி പൊസിഷനിൽ நான் செட் பண்ணி வச்சேன். This is giving the output as but only 10%, means very less. But this interlock has been closed, which means that it should be some 33%. Means analog value and digital value are mismatching. Maybe some interlock problem irkalam, illana analog transducer problem irkalam. In such cases, we have defined a tolerance value to declare as angle transmitter failed. The last month 37387 we got failure. In that, this digital interlock has failed, but this analog value was reading some higher value. So there is a mismatch between analog value and digital value. Okay. In such cases, FLG processor will give the command that if there is a mismatch in analog and digital value within some tolerance. Previously it was 30% tolerance. Means analog is showing some 60 and digital is showing some 10. Then error will come. And message will display that angle transmitter failed. Okay. Similarly, since angle transmitter failures got increased in one time, 2 years back we have increased the tolerance limit little bit more. Okay. Now PPO what they are doing is they will make this failure mode switch on and test everything whether it will work with failure mode or not. Okay. Now it is clear. Then how to check angle transmitter interlock analog values in driver display unit? So menu la input output signals or option irukku. In this analog signals also we can see, digital signals also we can see. In analog signals, if you are in cab 1, you should select FLG 1. If you are in cab 2, you should select FLG 2. Okay, then this is X angle transmitter, means how much angle we are giving, that value will be displayed in this percentage. So in low cost standstill condition, without powering on, you can move the angle transmitter without powering on. That is very important. You can just move in 504 node and see from 0 to full 100%. This percentage value is giving or not. This is the way in which we can test angle transmitter in loco itself. And second, I have told you about analog only. Now digital also we can see. Digital signals you can select. Then it will, whether it comes under cab 1 means it will be driven by STB1 card. Now it is cab 2, so I have selected STB2. In that, input signals will be there, which is given by angle transmitter. you can see that direction, forward or reverse, that will be turning on or turning off as we move the switch or knob. Similarly, under HBB2 also we can see, and this digital interlocks 1 by third, 2 by third, like that. Everything you can see in driver display unit. If you are moving this to that position, this value will be turned on, otherwise it will display off. Like that we can check in loco itself. Full signals, this is forward reverse, then 1/3, 2/3, everything. From both cabs we can see. If cab 1 means STB or HBB, you select 1. Cab 2 means STB2 or HBB2. Okay. Then transformer temperature monitoring. For that, one SR is having 2 elements. Means elements will be, its temperature based resistance will vary. So as temperature increases, we know that some materials like PT100 and all, its resistance will be varying, and that variation in resistance is sensed by SR. Okay. So there will be, per each SR, 2 elements will be there. So togetherly 4 elements will be there in locomotive to sense transformer oil temperature. Similarly, pressure also will be sensed by 2 elements will be there at the inlet and outlet, and that pressure difference by concerned by one differential amplifier. That amplifier output will be given to traction converter. Okay. So that sensors will give input to traction converter, and how it works. So if the temperature is has crossed 84 degrees or above, then VCB will trip, and proportionally to that rise in temperature after 80 degrees Celsius, traction will be limited. Then this is the normal logic which we are using. I told you that 2 elements are there. If the difference between that 2 elements, if for same SR, one element is reading as 10 degrees and one element is reading as 50 degrees, higher will be considered always. Other element will be ignored. Similarly, if the difference is low, means always higher value will be displayed. So totally in loco 4 elements are there. All the 3 are showing 55 degrees Celsius and one is showing 200 degrees Celsius. Then that will be eliminated. Only remaining 3 will be considered. Like that only its logic works. So there is a small variation in logic between ABB, VTIL, MEDA. A very propulsion to propulsion, small differences will be there. But the overall concept is same only. This is for MEDA logic. And how to check this? In that menu option, temperatures are available. That temperature we can go and SR how much, transformer oil how much, like this values we can see. And one more thing, if loco is placed like this and sunlight is coming from this side, in some 2 or 3 hours, if loco is continuously working, some 3 to 5 degree difference we will get from SR1 to SR2 or from transformer oil from 1 to 2 temperature difference. That may not be considered actually. Okay. Then pressure also, like this we can check. Options pressures are there. This pressure will be displayed here. For this pressure also, if it is BTIL loco, we will get around 900 and something millibar value. If that difference is more than 100 between transformer oil pressure 1 and 2, then only we have to consider. Otherwise, we can neglect it. For ABB, we will be normally getting around 1.8, that range pressure. And for MICA, it will be very less, 0.8, 0.9 range we will get. Like that, we can compare. If there is a huge difference, then only it will be taken into account. Otherwise, it will be ignored and working can be continued. If problem is there, means converter itself will give message to us while working. This is for BTIL, how to check value. That's all.